Hello, fourth grade, and welcome to lesson 2 of Unit 5 or Module 5 in science. So we're working on the patterns of Earth's changing features, and we are beginning lesson 2 today, the effects of erosion. So let's go ahead and watch our short little video clip here, and then we will get started with our lesson.
Hi, my name is Maya. Take a look at what I found while hiking. To most people, this is just a rock, but I want to know so much more about it. How did it form? What is it made of? What type of rock is it? How old is it? When I grow up, I want to be a geologist. Then I can study rocks all the time. Geologists spend a lot of time outdoors. Prepare to get dirty. Geologists do a lot of digging. You never know what you'll find when you are a geologist. I have even found rocks with fossils. This one's going right in my rock collection. I don't think I have this one yet. Happy digging!
All right, let's go ahead and jump into our lesson. So as always, we've got our lesson title, our module here, Pattern of Earth's Changing Features, Lesson 2, Effects of Erosion. And we're going to begin, as always, with our first page. So you're going to read the scenario, decide which of the 3 friends you agree with the most, and then you're going to explain why you agree. So remember to use complete sentences, always check your spelling and grammar, make sure you're capitalizing and you're adding punctuation at the ends. Once you've completed that, we're going to take a look at a photo of a landslide. You're going to write down at least 3 questions you have about what's happening in the picture, and then we're going to read about the soil conservationist. So let's go ahead and take a look at that picture together. And feel free to pause the video so that you can get a better look at it. So here you can see the landslide. You can see everything that's coming down onto this residential or housing area underneath. Write down your 3 questions. Once you've completed that, go ahead and read about the soil conservationist. Once you've completed your reading, you're going to answer these 2 questions. What does a soil conservationist do? And what could happen if a farm did not use soil conservation methods? Remember, when you're writing out your answer, to pull part of the question into your answer to make it complete. So for number 1, where it says, what does a soil conservationist do? You're going to start your sentence by saying a soil conservationist, and then tell me what they do. For the second question, if a farm did not use soil conservation methods, then, and you would tell me what would happen. And then give your best guess to our essential question, how do living and non-living things change Earth's surface? So we're going to study more about this as we go through our lesson. For now, give it your best guess, and then we're going to move on. Now, our first inquiry activity is called shake, rattle, and roll. So you're going to use a model and show how you can model weathering using rocks and moving water. So you're going to have your safety goggles, you're going to have some jars with lids, some sedimentary rocks or sandstone rocks, measuring cups, water, a stopwatch, and a hand lens or a magnifying glass. So what's going to happen is the first thing we're going to do is write out our prediction. What will happen to rocks if you shake them in water? So then we're going to go through. After you finish writing your prediction, we're going to carry out our investigation. So we're going to label 3 jars. One is the no shake jar, one is the 2-minute shake jar, and one is the 5-minute shake jar. So you're going to put the same amount of similar sized rocks in each one, and you're going to use the measuring cup to fill them with the same amount of water. You're going to put the lid on each jar. You're going to leave the no shake jar and just let it sit. For the 2-minute jar, you're going to shake it for 2 minutes and let it sit. And you're going to do the same thing for the 5-minute jar. You're going to shake it for 5 minutes and then let it sit. Then you're going to use your hand lens or your magnifying glass to observe what's going on in those jars. So write your observations, be detailed, write as much as you can to describe what it is that you're seeing. After that, we're going to answer our questions. How can rocks change in moving water? What do you think would happen if you shook the jar for an hour? How did your results compare with the prediction that you made? So after you answer those questions, you can share with a partner and see if you guys found the same results. Moving forward, we're going to take a look at our vocabulary for this lesson. So our vocabulary words are the words weathering, acid rain, vegetation, erosion, deposition, landslide, and avalanche. Let's go ahead and pull up our vocabulary words and their meanings. So weathering is the breaking down of rocks into smaller pieces. So when rocks start to break down and pieces start to chip off and they break off and they become smaller pieces, we call that weathering. Acid rain is harmful rain that's caused by burning of fossil fuels. So the burning of those fossil fuels causes these chemicals to mix with the rainwater. And when it rains with those chemicals mixed in with the rainwater, all of those acids, all of those chemicals that are in the rainwater will damage things like buildings or statues. And you can see that they're worn down in places because of that damage. Vegetation are plants that cover a particular area. So any kind of plant life in an area, we call it vegetation. Erosion is the weathering and removal of rocks and soil. So when it's being broken off, when it's being taken away, it's eroding. We call that erosion. Deposition is the dropping off of eroded soil and bits of rock. So think erosion is happening when a river is passing through an area and bits of rocks are being carried away by the river. Deposition is when those bits of rocks find a space to stop. So they're being deposited or they're being put or dropped off in those particular areas. That's deposition. So that's where those crumb pieces that broke off, where they're settling afterwards. Now, a landslide is the rapid movement of rock and soil down a hill. So when rocks and soil and dirt all of a sudden start to move very quickly down a hill or down a slope, we call that a landslide. An avalanche is basically the same thing, but with ice and snow. So it's an ice and snow landslide. You're having big pieces of ice and snow that break off and all of a sudden come moving down a hill or a mountain in a similar way. Now let's take a look at our first video that we're going to watch today. This is called Weathering and Erosion, and this is going to cover the process that changes Earth's surface. So let's go through our questions first, as always. That way, once you're coming across your answers, you can fill them in. Question number 1 says, what do you think causes the changes in the landforms and man-made objects you observed in the video? So what do you think is making those changes happen? Number 2, how do you think the beach in the video will change? Number 3, when do erosion and weathering occur? So when do those things happen? And number 4, how can human activities change the way that weathering and erosion affect landforms? So what are things that people do that can change the way that weathering and erosion is affecting the land? Let's go ahead and watch our video together.
Did you know that rocks move and change shape? This rock hasn't always looked this way. What do you think happened to this rock to make it look this way? Do you think the Grand Canyon always looked like this? Things that people build also change over time. These man-made structures have changed significantly through the years. In what ways do you think the Statue of Liberty has changed from how it originally looked? Do you think that this beach will look different in the future?
Okay, so let us take a look at our questions one more time. What do you think causes the changes in the landforms and man-made objects that you observed in the video? So if we're going back into the video and we're looking at some of these things that changed throughout the video, looking at the Grand Canyon and how that formed, looking at some of these different structures and seeing how now you can see they're broken down, but when they were originally built, they definitely didn't look that way. Looking at the different things that we're seeing, the Statue of Liberty, the Sphinx, all of these things, how did they get to looking the way that they look now? Because this is not the way they originally looked when they were built. And taking a look at the beach. So remember, we talked about water kind of carrying off pieces of rock. Do you think this beach is going to continue to look the same if waves are constantly hitting these rocks? What's going to happen to that beach over time? Take time to go through and answer your questions. And for number 4, how can human activities change the way weathering and erosion affect landforms? Again, we can go back to what we were reading previously about acid rain, and pollution and things like that, that will help you to find your answer for that question. Now let's go ahead and pop open our textbooks, and we're going to read pages 162 to 165, and we're going to answer these questions after we finish reading. The first question says, define weathering. So give the definition. Tell me what weathering is. Number 6, list the different types of physical weathering. So there's going to be more than one. Tell me what each one is and what it does. And then we're going to continue on to our page. So let's go ahead and start reading in our textbook. Earth's changing surface. Forces within Earth build up the crust into mountains, plateaus, and other landforms. At the same time, processes such as weathering break down the crust. Weathering is the slow process that breaks down rocks into smaller pieces. So that's part of one of our questions right there. Physical weathering. Rocks can change size and shape without changing their chemical properties. This process is physical weathering. Ice, wind, water, gravity, plants, and animals cause physical weathering. Animal actions. Many animals, including moles, gophers, and prairie dogs, worms, ants, burrow in the ground. These animals can loosen and break apart rocks in the soil as they move. Plant growth. Plant roots enter cracks in rocks. As roots grow, they force the cracks apart. Over time, the roots of even small plants can pry apart cracked rocks. So take a look at what's happening over here. You can see how these roots have kind of grown in between these different rock formations. The actions of living things, such as the burrowing of animals or the growth of plant roots, can cause weathering. Freezing and thawing. Water can seep into cracks in a rock during warm weather. When water freezes during cold weather, the water expands and makes the crack bigger. This process, called frost wedging, also widens cracks in sidewalks and causes potholes in streets. Abrasion. In nature, the action of rocks and sediments grinding against each other and wearing away surfaces is called abrasion. Abrasion can happen in many ways. When rocks and pebbles roll along the bottom of a swiftly moving river, they bump into and scrape against each other. The rubbing and scraping knocks the sharp edges off of the rock. Often river rocks are smooth and round from being tumbled in moving water for many years. Wind also causes abrasion. When wind blows sand against exposed rock, the sand wears away the rock's surface, the way sandpaper scratches wood. Abrasion also occurs when rocks fall and tumble against one another. During a rock slide, gravity pulls a mass of rocks down a hill. The rocks crash into one another as they fall. The force of the rocks hitting each other knocks pieces off of the rock. Anytime one rock hits another, abrasion takes place. The crashing of rocks together in a rock slide causes abrasion, a type of physical weathering. So let's review what we read over here so far. So we talked about animal action. So if animals are constantly digging and moving through dirt, they're going to be chipping away and breaking apart some of those rocks. When a plant is growing and a root starts to grow in the crack of a rock, as that root grows, it's slowly going to continue to force that rock opening to open even wider, which is going to cause that rock to break apart. Now, freezing and thawing, this one's interesting. So when water gets into cracks between rocks or in sidewalks or on the street where you guys see your parents driving, the water there by itself isn't doing much when it's not moving. But when water freezes, it expands or it gets bigger, and it'll take up more space than it did when it was in liquid form. So as it freezes and gets bigger, it's causing these cracks and breaks to open even wider, which is what's causing the damage. And abrasion is basically anytime there's anything rough scratching against something else. So if you guys have seen sandpaper, we've used that in the classroom for other experiments. It's rough. So when you rub something rough against something else, it's going to take off kind of those sharp edges, and it's going to start to smooth it out. So we talked about a few different ways that abrasion happens. We talked about abrasion that happens in a body of water, like a river, where things are constantly being tossed around by the water. So it smooths it out because these rocks are being carried around and bump into each other. We talked about abrasion that's caused by the wind. So if it's an area that has a lot of sand, sand is rough, like sandpaper. That's where we get, the term sandpaper from, or where we get the idea of sandpaper. So those rough particles of sand constantly blowing against a sharp rock surface is going to slowly smooth it out over time. And a rock slide, where they're falling and tumbling against each other, is going to break off those sharp edges as well. Let's keep reading. Chemical weathering. Chemical weathering changes the minerals that make up rocks. Water, oxygen, acids, carbon dioxide, and living things all cause chemical weathering. Water. Water causes not only physical weathering, but also chemical weathering. Rainwater is naturally slightly acidic. Water is sometimes called a universal solvent because water dissolves many types of minerals, including rock. Small amounts of acids from natural sources, such as volcanoes, can make precipitation more acidic. Remember, precipitation is just a fancy way of saying any type of water falling from the sky, whether it's in water form or snow or hail. These acids speed up the breakdown of rocks. Precipitation that contains acids from air pollution is called acid rain. Acid rain contains more acid than normal rainwater. It can cause very rapid weathering of rocks. Oxygen. The oxygen in air causes chemical weathering. Iron combines with oxygen in the presence of water to form rust. Like an iron fence, rocks that contain iron can rust. Rust makes rocks soft and crumbly and gives it a red or brown color. Living things. Plant roots not only break apart rocks, they dissolve them. Plant roots give off a weak acid as they grow. The acid dissolves the rocks that the roots move through. Lichens, which are plant-like organisms that grow on rocks, also produce weak acids. Lichens are important in soil formation in cold climates. Acid rain has weathered this monument. Human activities contribute to the production of acid rain. So here, if you look at it, you can see that it's not a smooth sculpture anymore. You can see that it looks like pieces have slowly been chipped away or broken off, and this is due to the acid rain. So the pollution that mixes in with that rainwater that's causing these rocks to break down even faster. Lichens produce acid that helps cause the chemical breakdown of rock. So here you can see even the rocks are looking rusty, and that's because the iron in the rock is mixing with the oxygen and it's mixing with the water and those acids, causing it to rust the same way we would see metal rust when it's left outside. Carbon dioxide. Another gas found in air, carbon dioxide, also causes chemical weathering. When carbon dioxide is dissolved in water, it forms a weak acid called carbonic acid. This acid easily weathers marble and limestone. Caves and sinkholes. Carbonic acid in water is responsible for the formation of limestone caves and sinkholes. Carbonic acid chemically reacts with the calcite in limestones. The limestone dissolves in the water and is carried away. In time, this process can form a cavern. There are limestone caverns in many places throughout the United States. Some places, such as Florida, are well known for their sinkholes or holes in the ground. A sinkhole forms when the ground collapses because of chemical weathering in limestone rock beneath the surface. Stalactites and stalagmites in caves also form by chemical weathering. These features form from limestone-rich water that percolates through the rock and enters the cave. The water evaporates slowly, leaving behind these interesting rock formations inside the cave. Chemical weathering can result in natural features of caves called stalactites and stalagmites. Cracks form in limestone. So here's the surface and here's the water, and you see these cracks that are forming in the limestone. Carbonic acid in rainwater reacts with limestone underground. Groundwater carries the dissolved material away. Eventually, a cavern forms. So you can see that it slowly gets carried away, and then you end up with this cavern. It almost looks like an underground cave. So let's review what we talked about here. Physical weathering we talked about before doesn't change the chemical makeup of the rock. Chemical weathering does. Now we see water in both areas. We see water in physical weathering when it's not particularly acidic, but we also see it in chemical weathering in the form of acid rain. Here we also talked about how acid rain is breaking things down and it's dissolving parts of the rock. How oxygen, when it combines with iron and acid rain, it causes rust. We talked about how plant roots and these plant-like organisms called lichens also give off mild acid that slowly causes things to also break apart, that also causes the rocks to slowly break apart. We talked about carbon dioxide causing chemical weathering and how that carbon dioxide, when it's dissolved in water, forms an acid that we called carbonic acid. Now, this carbonic acid is what is responsible for these really amazing looking caverns and caves that have rock features called stalactites and stalagmites. And these happen when you have a cave or an area that has a lot of limestone in it, that carbonic acid starts to dissolve it and it forms these beautiful rock formations. All right, let's go ahead and get back into our book. So define weathering, that was one of the first things we read. And then it says list the different types of physical weathering. So the physical weathering was on our previous page. So we have our animal actions, plant growth, freezing and thawing, and abrasion. Those are our different kinds of physical weathering. Now for the next section, our inquiry activity, it says weathered by vegetation. You'll investigate plants growing outside to collect evidence that plants can cause weathering. What evidence do you think you will observe that you can show how vegetation can cause weathering? So list your ideas over here. Then we're going to go ahead and head outside. You can do this from home or you can do this in the classroom. Anywhere you are, you can do this activity. So you're going to go out and look around and look at where plants are growing and look at the effects that they're having. Are you seeing any cracks in maybe the rocks or the stone area or the pavement where they are? Record your data. So you're going to look at 3 different locations and write your observations. And then we're going to go ahead and answer our questions. It says, using the data you collected, explain how vegetation could cause weathering. How did your prediction compare with what you observed? Then we're going to hop back into our textbook one more time, and we're going to read pages 166 to 171. And we're going to answer these questions. What is erosion and what is deposition before we jump into our next page? Erosion and deposition. Erosion is the process of weathered rock moving from one place to another. The process of eroded materials being dropped off in another place is called deposition. Erosion and deposition work together to change the shape of the land. So before we move on, let me explain these terms to you because I know sometimes we get them mixed up. So let's go back and talk all the way from the beginning about weathering. Now, weathering, we said, is when rock pieces are being broken off. Erosion is when those rock pieces that broke off are being carried away. And then deposition is where they're being deposited or where they're being dropped off after they've been carried away. So where did they land? Where did they end up, staying after that? Erosion and deposition by gravity. Gravity is a powerful agent or cause of erosion. Gravity causes mass movement, the movement of sediment downhill. Now, sediment is basically just small pieces of broken off things. So small pieces of rocks that broke off, we call those sediments. Mass movement can be fast or slow. Mudslides, landslides, and rock slides are all fast movements of a large amount of material down a slope. All of these events may occur after an earthquake or volcanic eruption that causes the ground to move. This movement loosens the sediment. Gravity then pulls the material downhill. A slow mass movement is creep. It occurs over years as particles of soil slowly move downhill. So they're creeping down the hill. Erosion and deposition by running water. As water runs downhill, it can wash away soil and erode rock. The water, soil, and rock will eventually flow into a larger body of water, such as a river. Rivers with fast-moving water tend to follow straight paths and have deeper channels and steeper banks. Fast-moving water has more energy. It can wash away a larger amount of heavier sediments. Rivers with slow-moving water tend to follow a curved path and have shallow channels and low banks. Slow-moving water has less energy. It carries smaller particles of sediment. The looping curves of this river are called meanders. Slow-moving water deposits sediments on the inside of a meander. Faster-moving water erodes sediment on the outside of meanders. So let's stop and take a look at what we were talking about. Now we're talking over here about gravity specifically and how gravity plays a part in erosion and deposition. So gravity is a force that pulls things downward. Now, if you have things that are on a higher elevation, like on a mountain or on a hill, and we have something occur like an earthquake that causes those things to move around and loosen, gravity is going to be one of those things that pulls them down and causes them to move downhill, to erode. And then they'll be deposited at the bottom of that hill or mountain. So that's where the deposition happens. So it can be either fast moving, like a landslide or a mudslide, or it could be a slow moving downward motion that we call a creep. Now, erosion and deposition with water happens usually when it's moving through a larger body of water, like a lake, or not a lake, sorry, like a river. Now, bigger rivers usually move in straight lines and they move very quickly. So they have a lot more energy. So they're able to move and pick up and erode larger pieces of sediment. Remember, sediment we said is like broken off pieces of rock, things that have chipped off. They can carry those bigger pieces because there's more energy. Smaller rivers that are usually a little more windy, they don't follow necessarily a straight path, can't always carry the bigger pieces, but they'll carry the smaller pieces and they'll deposit them around these curves that we call meanders. Rivers eventually flow into a larger body of water, such as a lake or an ocean. Since the water is no longer flowing downhill, it slows down. The sediment carried by the water is deposited at the bottom of the lake. Over time, this sediment builds up into a landform called a delta. Rivers also deposit sediment when they flow out of a steep, narrow canyon. Here, the stream becomes wider and shallower. The water slows down as it spreads out. Sediments are deposited in an alluvial fan. When water enters a still body of water, it slows and drops its sediment. So it's all those pieces of rocks and things that it was carrying will settle down at the bottom. Erosion and deposition by wind. Wind can move sand from one place to another. When wind blows over the land, it picks up the small particles of sediment. The stronger the wind blows, the larger the particles it can pick up. All the sediment eroded by wind eventually is deposited. So all those pieces that are picked up by the wind will eventually get dropped somewhere. Deposition occurs when the wind slows or when a clump of grass or rock traps the sediment. A sand dune is a deposit of wind-blown sand. Sand dunes come in many shapes and sizes. Dunes move over time. Little by little, the sand shifts with the wind from one side of the dune to the other side. Sometimes plants begin to grow on a dune. Plant roots can help keep a dune from moving. Dunes are deposits of wind-blown sand. As the wind continues to blow and it moves up and over the top of the dune, the sand moves the dune forward. Erosion and deposition, erosion by glaciers. In very cold places, thick sheets of ice called glaciers creep down the land. Over 1 million years ago, glaciers began to cover much of the earth. Few places are cold enough for glaciers today. Glaciers form when snow collects quickly and melts slowly. Year after year, the snow builds higher and the weight at the top of the mound puts pressure on the snow below. The snow in the lower layers of the glacier slowly turn into ice. Near the ground, the pressure from the snow above causes some of the ice to melt. As the weight of the ice increases, the glacier begins to flow on the land on the layer of melted ice. The bottom and sides of the glacier freeze onto rock. As the glacier continues to move, it tears rock from the ground. It scratches, flattens, breaks, or carries away things in its path. A glacier can make a valley wider and steeper. It can even carve grooves into solid rock. Read the diagram. The dark lines in the center of the glacier are eroded sediments. Trace the lines to the point where the sediment is deposited. So over here, you can see that it's slowly moving down. And at the bottom is where you're going to see that sediment, where it gets dropped off. Deposition by glaciers. Glaciers not only erode the land, they deposit the eroded rock. As glaciers melt, they leave behind the rock that they carried. The leftover rocks are called glacial debris. Glacial debris can be made of large boulders or small particles. It can have bits of gravel, sand, and clay. This mix of materials is called glacial till. The glacier drops most of this debris at its downhill end or terminus. Materials that the glacier picks up or pushes can form mounds. These mounds are called moraines. Not all glaciers leave moraines behind. Sometimes the melted water from the glacier washes the material away. Today, glacial till is scattered across Canada and the northern parts of the United States. Glaciers can erode solid rock. These grooves were formed as the glacier moved across the land. These large borders were dropped by a glacier when it melted. So as the glacier forms, what happens is you have a lot of snow falling in a short amount of time, and it piles up really high. Now the weight of that snow gets really heavy, so it pushes down on the bottom layers of snow and it solidifies it. It turns it into solid ice. Now eventually there's so much pressure and weight from this giant glacier that's forming that the bottom of it will start to melt and you'll see it start to move. So what's going to happen is as there's more snow falling, even though the bottom is melting, it's also dropping over things like rocks and other landforms and kind of clinging onto them, right? It's melting and solidifying onto them. So when that glacier starts to move, it's ripping out parts of these rocks and things that it was holding on to as it starts to shift downhill. If there's things that are in the way as it's moving, it will carry or crush or move those things with it as well. And then it deposits all of those things that it picked up towards the bottom. Erosion and deposition, shorelines. Wind, water, and waves combine to erode and deposit sediments along the shorelines. A shoreline is where the land and a body of water meet. A lot of energy is released when waves hit a beach. A large wave can break solid rock or throw broken rocks back against the shore. The rushing water in breaking waves can easily wash into cracks in rocks, helping to break off larger boulders or fine grains of sand and sediment. The loose sand picked up by the waves polishes and wears down coastal rock. Waves can also move sand and rocks and deposit them in other locations, forming beaches. A beach is any area of shoreline made of materials deposited by waves. Some beach material is deposited by rivers. Other beach material is eroded from areas near the shoreline. The movement of sand along a beach depends on the angle at which the waves strike the shore. Waves often hit beaches at an angle or a curve. As they strike the shore, the waves pick up sand and rocks and move these materials farther down the beach. When the waves reach a headland or an area of land that has water on three sides, they curve around it and wash away the sides of the headland. As the waves continue to erode the sides of the headland, an arch forms. So here you can see how, let me zoom in here if I can. No? Okay, I guess I can't. So here you can see how the water is coming around this area. Now, as it's coming around, it's going to wear away the edges more and more. And that's how this formed right here, this arch, because the water is rushing around it and it's constantly hitting and scraping at the sides that will eventually wear it down and create this hole or this arch. Sediments are also deposited along shorelines away from the beach. Waves moving at an angle to the shoreline push water along the shore. A longshore current is a movement of water near and parallel to the shoreline. Sometimes waves erode materials from the shoreline, and a longshore current transports and deposits it offshore. A sandbar is an underwater or exposed ridge of sand or gravel. Barrier islands are large sandbars that stretch for long distances along a shoreline. Barrier islands protect the coastline from erosion caused by large waves during storms. The waves hit the barrier islands first and erode them rather than the coastline beaches. After several storms, barrier islands may be so completely eroded that they no longer appear above the water. Without the barrier islands, the coastline erosion would be worse during the next storm. Some coastal areas have one or more sets of dunes running along the shoreline, directly inland from the beach. As in deserts, coastal dunes form when wind erodes sand and it deposits it in another area. As the wind blows, it picks up sand from the dunes closest to the water and blows it farther inland. Dunes protect the inland areas from large waves that occur during storms. Dunes also shelter inland areas from wind if severe winds or waves occur. Dunes may be completely eroded. Wind blows sand away from the front of an ocean beach and forms dunes as these. So sometimes you'll be going to the beach and you'll see kind of a little sand mountain. And the reason that formed is because wind is picking up sand from right at the beach, right at the shoreline, and blowing it farther inland away from the water. And so it starts to pile up, and that's how you get these little sand dunes that are at the beach. And these are our sandbars that we were talking about. So you can see that it's kind of just this raised up landform in the water that will protect the shoreline from large waves, from things like that are coming, because all of that is going to hit the sandbar first before it gets to the shoreline. All right, let's go ahead and jump back into our reading or into our workbook. So what is erosion? What is deposition? You're going to go ahead and list those. Now, next we're going to get onto this page called dwindling mountains. How does the rate of erosion affect a landform? In the table below, you'll see the heights of some mountain peaks in the United States. So here are the different mountains, the state that they're in, their height in meters, and then their height in feet. And to find the number of years, you can count backwards from by twos from 6,194 meters to 6,174 meters. It would take about 10 years for the mountain to become 6,174 meters tall. Another way to solve this problem is to find the number of meters lost. So you can do that by subtracting and then dividing. So mountains erode by small amounts each year. Suppose Mount McKinley eroded 2 meters each year. So here's Mount McKinley in Alaska. And if we're working with meters, we're starting looking at the height in meters, so 6,194 meters. How many years would it take the mountain to be 6,174 meters tall? Follow the steps of the problem-solving box. So this is what we were just looking at. Use a separate sheet of paper to solve the following problems. If the erosion rate is 1 meter each year, what will be the height of Mount Shasta in 20 years, Mount Whitney in 15 years, or Wheeler Peak in 80 years? So go ahead and solve those. You don't necessarily need a whole other sheet of paper. You can work on the side if your handwriting isn't too big. Otherwise, do feel free to attach a piece of paper to show your work. All right, so let's see. We are going to move on, and instead of doing the activity that you guys have here, what we're going to do is we are going to watch a Generation Genius video. So we're going to close this out. And here we're going to look at our investigation on the effects of erosion on landforms by conducting the simulation. And then we're going to answer the question after you finish. So notice over here, you have a lot of lines. That means your answer has to have a lot of details. You need to describe everything really carefully. So 1 or 2 lines is not going to be enough answer here. Choose one of the causes for weathering and erosion. Explain how that process changes different landforms over time. Include in your explanation how the process weathers and then erodes the landforms. After you complete the activity and your explanation, share your response during a class discussion. So you're going to be doing a couple of things here. Now let's go ahead and take a look at our investigation. One moment, let me find it for you guys. Here we go. Okay, erosion is the process in which rocks and sediments are picked up and moved. Water, ice, wind, and gravity can cause erosion, with more than one of these forms affecting the land and at the same time. The effects of erosion take place over hundreds of thousands of years. Select the landform and then choose a form of erosion. Select play to see the changes to the landform over time. So here we can start at the top. We'll start with a mountain, and we can see how water is going to erode it over time. So we're going to hit play, and you can see over here how that water is weathering and eroding this mountainside. Now, if I were to take it off, you take the river out, you can see how it kind of dug itself, kind of this trench down the side of the mountain. So if we're going to look at the comparison, the before and the after, you can see that the water caused parts of the mountain to break off. So it caused weathering. And then the water also caused erosion where it was picking up those pieces that broke off. And deposition is where it deposited it somewhere else. Okay, so let's reset and we can still work with our mountain, and let's see how ice is going to affect our mountain. So here's our mountain and here's ice, and let's see what ice is going to do. So you can see as it starts to melt, you can see part of the ice melting and flowing down. And you can see that again, it kind of dug out a path in this mountain that wasn't there before. So you can see the effects that it's having. Okay, what about wind? So let us reset one more time. And let's see how wind is going to cause changes in our mountain. All right, so take a look at our before and our after. So the wind is picking up small pieces of sand and dirt and rocks and carrying it. Now, as those small pieces are rubbing and hitting the side of this mountain, you can see that it's smoothing out those sharp peaks, right? Because it's constantly rubbing like sandpaper. Now, if that wind continues to blow, you can see that it's slowly wearing away more and more of the mountain. All right, let's try a different one. Let's see how the mountain is affected by gravity, and then we'll try a couple of the other ones. So if gravity is constantly pushing down, causing these rock slides and these landslides, you can see how parts of the mountain are being broken and chipped off, and they're eroding and being deposited at the bottom over here. Okay, let's try a crater, and we'll see how ice affects a crater. So a crater is kind of this large indented area of land where it's lower and it's dipped in more. Now, if we have a crater that's filled with ice, so that ice is eventually going to melt in some areas, and we can see that the crater doesn't move, but there is some amount of erosion here. Now let's take a look at a plateau. So a plateau is a raised up flat area of land. So it's, think of it like a mountain, but with the top pointy bit cut off. It's flat and it's raised up like a mountain. So let's see how wind will affect our plateau. So remember, wind is carrying pieces of rocks and sand that's slowly going to wear away and smooth out any rough edges that we've got. So as you're seeing this change, you can see that it's slowly wearing away our plateau. And our plateau is not only smoothing out around the edges, but it's also becoming smaller and smaller. And then we can take a look at a plateau and see how water would affect it. So if we have water running down this plateau, so we have our waterfall here. If we hide that, we can see over here that it's kind of dug a path and an opening over here for where the water is deposited. So let's say that water keeps flowing, that waterfall is there for a longer amount of time, and you're able to see the difference here. So it's dug in even farther. Our area where the water is being deposited and where it's constantly hitting into the rock is deeper and wider. Okay, so you can go ahead into your page over here, and you can choose one of the causes of weathering and erosion that we talked about. So ice or water or wind or gravity. And explain how it changes different landforms over time. So we looked at a couple different landforms. Include in your explanation how that process weathers and then erodes the landform. So how does it happen? What is it doing? Give me the step-by-step. And then make sure you go back and check your work carefully. Okay, and finally, we're going to hop into our last pages and take a look at our essential question. How do living and non-living things change Earth's surface? Think about the photo of the landslide that you saw at the beginning of the lesson. Explain how events like the landslide change Earth's surface. So we can go ahead and jump back and take a look at this picture so you can see that landslide over here, and you can see the homes at the bottom. And then you can go ahead and answer your question. Remember to use complete sentences. You don't need to complete the I did statement. Once you're done with this, please go back and review your work really carefully and make sure that you are practicing for your quiz. If you have any questions, let me know. Otherwise, I hope you have a great day, fourth grade. Take care. Bye-bye.